All right. So, well, thank you for attending this session about the progress of our inter-scheme or multi-scheme, because I saw it in the agenda. It's actually called inter-scheme, multi-scheme, but we tend to call it inter-scheme. So basically, the objective of the work stream was to define, and we will discuss later about the build, but how the connection between two Moja Loop instances would work, and understand and orchestrate how payment can seamlessly flow from one instance of Moja Loop to another. Whilst effectively this design could potentially also apply to two non-Moja Loop or one Moja Loop instance and a non-Moja Loop instance. For step one, we actually focus on having two Moja Loop instances being connected in different sort of models that Michael will present in a minute. So it could be in a hub and spoke model, for example. So that was the objective of the work stream, focusing on the definition, understanding how exactly it would work in terms of design, and documenting all of this. Okay, so I think we'll switch to Michael's slide before I go into what we've done in summary and also introduce what we will do in the next PI. So please, Michael, can I give you the floor, and can you please give me 5 more minutes at the end?
Okay, if you insist. I can deny you nothing. Okay, so our objectives really were to be able to support inter-scheme topologies of arbitrary complication, i.e. Any sort of arrangement of communication between schemes. And as Julie rightly pointed out, this is not simply a matter of connecting Moja Loop schemes to each other, but also a matter of being able to connect Moja Loop schemes to non-Moja Loop schemes. We also wanted it to be invisible to participants, that is, the DFSPs. We wanted the DFSPs to work in exactly the same way they do now, without needing to know whether the payment they were requesting would be made to someone in their scheme or in some other scheme to which their scheme was connected. Third, we wanted to be able to support Moja Loop's inclusiveness features end to end, and that covers non-repudiation signatures, agreement of terms secured by cryptographic locks, deterministic finalization secured by timeouts, and the removal of the credit risk to participants by insisting on pre-funding. We also, of course, wanted it to be able to support currency conversion. So I'm going to be talking about 3 major topics in this. First of all, how we route messages between schemes. Second, how we record obligations across schemes. And third, the process for timing a transfer out. So let me start by talking about routing messages between schemes. And I've got an example topology here. One scheme there, another scheme, third, a fourth, and a fifth scheme. So each of them has 2 DFSPs attached, just for the sake of demonstration. And we want to connect them, first of all, a hub and spoke scheme, which covers schemes 1, 2, 3, and 4, where scheme 2 is acting as the hub. And you'll notice that it's not necessary for anything special to happen in the scheme 2 for it to act as a hub. It just has more than one other scheme connected to it. And then we've also got an in-series connection between scheme 3 and scheme 5. So you can get to scheme 5, but only by going through scheme 3. So how do we plan to do this? Well, we plan to use a proxy. So now I want to talk a bit about proxies. A proxy is a participant in 2 schemes. That is a participant DFSP. It's a DFSP which is registered in each scheme with a proxy role. And at the moment, our view is that you can have a proxy role, but you can't have any other kind of role. So we do not at present support DFSPs who are account holding institutions, but are also acting as proxies. That may come in the future, but for the moment, proxies are only proxies. It routes messages between the schemes, and that's basically all it does. This may include content conversion, or it may not include content conversion. This is an argument that we have frequently in this scheme, whether we ought to insist on it or not. But what I want to say at the moment is that this architecture takes no position on whether there is content conversion in the proxy or not. It works in the same way. We have defined a new header parameter, which a proxy will use to notify the scheme its role in forwarding the message. Now, this proxy identifier is not included in the non-repudiation signature, so proxies can add it as they want. It enables the switch to know that the message was forwarded by a proxy and did not come from a DFSP. And second, it enables the switch to know which proxy forwarded it. And the proxy may also participate in the moving timeout mechanism, which I'll be talking about later, though the example that I will show you doesn't require it to participate in that. Now, I want also to say that we expect a proxy to be operated by a scheme, or possibly by a pair of schemes. And that means that the settled funds accounts associated with a proxy may be owned and operated by the scheme. If that's the case, it's important to note that the position accounts in the two schemes will be mirror images of each other. Every credit to a proxy's account in one scheme will be matched by a debit in the other scheme, and vice versa. So those position accounts in the two schemes will always cancel each other out, which may be important for the process of settlement between schemes.
Sorry, Michael, can I just add something on this slide?
Please do.
One thing which is quite important is like operated by a pair of scheme. From a legal and regulatory perspective, you will only have one entity operating basically this account, because it will be decided with where the money sits, right? Because it is important when you look at insolvency perspective and which regulation apply. So technically, like there will be a single will account that will be operated by a single scheme.
I agree, but it's not necessary that that should be the case. It's possible that the accounts on different sides of the proxy might be in different places. And again, this is not something which is affected by the design. So either of those situations would work without any need to change the design. Okay, so moving on, I want to talk about how switches work with proxies. Now, when the switch receives a message, it checks the header to see whether it received the message from a proxy. You'll recall that I said that we're going to have a new item in the header that says whether it was a proxy that forwarded it or not. If the message was sent from a proxy, then that switch stores an association between the source DFSP, the DFSP that originally sent that message, and the proxy. And that essentially says, I got a message from the originating DFSP and it came to me via this proxy. So now the switch knows where to route a message for a DFSP which is not a member of its scheme. But it only needs to know the immediate route. It only needs to know which proxy to send the message to. So this architecture is topology agnostic. It works no matter how simple or complex the connections between schemes are, because each switch only needs to know which proxy to route things to. And each switch logs and processes the messages it receives in the same way as it does now, with some slight variations that I'll be talking about in a moment. Now, let's think about how we bootstrap the routing process. First of all, I want to say we need to answer a question which is a question about DFSPs, not a question about accounts. We're trying to find out where to send a message for a particular DFSP. Now, if a switch needs to route a payment to a DFSP it doesn't recognize, or doesn't know about, which will be the case with the get parties initial call, where the switch is trying to find out which DFSP speaks for a particular identifier, then first of all, it will identify all the proxies which are attached to the scheme, except the one from which it received the message, if it received the message via a proxy. It forwards the message to each of those proxies and stores the count of messages sent. If a proxy responds positively, then it stores the association between the proxy and the sender of the message. Otherwise, it decrements the count of messages sent, and if the count has reached 0, the DFSP can't be found and we raise an error. So that's how we can bootstrap the routing process. Now, I want to go back to what I said earlier and say, this is the process for the get parties call. So let's imagine that we have a new scheme, never been used before by anybody, and a participant says, I want to send a payment to this identifier. Now, there will be no routing information at present, and therefore the scheme will forward that request to each of the proxies that it knows about. They in turn will forward it to each of the proxies that they know about, and so on. It will propagate its way all across the system until somebody comes back and says, yes, I recognize that identifier, it belongs to me. Now, because those messages have been propagated across the system, the originating DFSP will be in the routing tables for each of the switches through which it's passed. So now when we need to send the message back, we have the information already that tells us it tells us where to send a message, which is going back to the originator. And as we go back across the channel, we can start adding the information about the responder DFSP as well. So when we do a successful get parties call, each switch will have a routing table that says which proxy to use for the originator of that request and which proxy to use for the recipient of that request. So that's how a routing table will gradually be built up. And of course, where entries already exist for that routing table, they won't need to be done again. They will simply be organized as part of substitution. Now, let's look at how this might work in practice. So I want to go back to my original question and say now, we have proxies in between all of the schemes like that. And each proxy, as you see, has its one scheme on one side and another scheme on another side. Now let's look at the routing tables. So over here, everything goes through proxy A. There's an entry for each of the DFSPs in the whole scheme, but there's only one proxy attached to this scheme, and therefore everything goes through proxy A. When we look at scheme 2, however, scheme 2 has 3 proxies attached, and now you can see that the proxy tables are distributed across the various proxies depending on how you get to it. And the important thing to note here is that for scheme 5, down at the bottom right, the proxy table says proxy B because the only route to scheme 5 is through scheme 3, which goes through proxy B. Scheme 3 now has, I shouldn't say proxy A there, shouldn't I? I should have said proxy B. Everything goes through proxy B except for traffic for scheme 5, which goes through proxy D. And here, these ones are much more simple. They only have one proxy each, so everything goes through that proxy. So now, let's look at how we route a message from DFSP 1A over there to DFSP 5B down on the bottom right. So first of all, switch 1 looks up its proxy. What I should say, first of all, is that the destination will always be the eventual destination, i.e. it'll be set to DFSP 5B when DFSP 1A issues the message. So switch 1 looks up its proxy table and routes the message to proxy A. Proxy A forwards the message to switch 2. Switch 2 looks up its proxy table and routes the message to proxy B. Proxy B forwards to switch 3. Switch 3 looks up its proxy table and routes the message to proxy D. Proxy D forwards the message to switch 5, and finally switch 5 forwards the message to DFSP 5B. So that's how the message travels across, navigates its way across the system based on the dynamically constructed routing tables between the various proxies. So that covers what I want to say about routing messages. Now I want to move on to the question of how we record obligations. Now, the rules for recording obligations for us will be as follows. Each scheme through which a payment passes will record the same information about the payment. When a payment is approved and it comes to creating the obligations, the rules are, if one of the parties to the obligation is reached through a proxy in this scheme, substitute the proxy's ID for the party's ID. And then if both parties to the payment have the same proxy ID, then don't record an obligation. Now I'm going to work through this with an example so we can see how that happens. You can see here a situation where we have a regional scheme and on the left and the right, two jurisdictional schemes, one for Malawi and one for Zambia. You will see that each of those has a proxy which connects the jurisdictional scheme to the regional scheme, which is a multi-currency one with currency conversion at the top. Now, let's take the example of a payment from Malawi to Zambia. Currency conversion is performed in the regional scheme, and we wind up, because of currency conversion, with two obligations. First of all, an obligation from the debtor party to the FXP in the source currency, and second, an obligation from the FXP to the creditor party in the target currency. And these exist in the same form in each scheme, except for the Zambian scheme, which simply receives a transfer request denominated in Zambian kwacha. Okay, I'm just going to take you back to the diagram so we can have a quick look at that so you can refresh your memory. So now, what happens in the Malawi scheme? The FXP in that scheme is reached through a proxy. So in obligation 1 and obligation 2, we substitute proxy A for the FXP. But also, the creditor party doesn't belong to our scheme, so we also substitute proxy A for the creditor party in obligation 2. Now, the result is we have one obligation from the debtor party to proxy A in Malawi and kwacha, but proxy A appears on both sides in the second obligation, which is going from the regional scheme to the Zambian jurisdictional scheme, and therefore we don't record it because it doesn't do anything in our scheme. What happens in the regional scheme? Oh, sorry, my mistake. The creditor party and the debtor party are both reached through a proxy. So we substitute proxy A for the debtor party in obligation 1, and we substitute proxy B for the creditor party in obligation 2. The result is that we record an obligation from proxy A to the FXP in Malawi and kwacha, and we record an obligation from the FXP to proxy B in Zambian kwacha. So that's the regional scheme. Now, in the Zambian scheme doesn't need to know anything about currency conversion. As far as it's concerned, it's simply receiving a payment in Zambian kwacha. So we substitute proxy B for the debtor party in obligation 1, and we record an obligation from proxy B to the debtor party in Zambian kwacha. So now we can see when we look back to our diagram that we've got what we want. We've got an obligation from the original debtor to the international payments account in the proxy of 1,000, let's say, Malawi and kwacha. In the regional scheme, we have a debt from the international payments account in the regional scheme to the FXP of 1,000 Malawi and kwacha, and an obligation from the FXP to the international payments account of the Zambian scheme of 20 Zambian kwacha. And over in the Zambian scheme, we have an obligation from the international payments account to the eventual creditor, DFSP2. Now that means that each of the obligations balances in each of the schemes, and we have decoupled the necessity for settling from the connection between the schemes. So each of these schemes can settle separately from any of the others. They can settle on their own timetables, and as long as working capital is provided, everything can work independently. Every scheme can work independently of everything else. So that's what I have to say about creation of obligations. Next, I want to talk about timing a transfer out. Now, the background here is that we need to distinguish between two landscapes. The first is before the creditor DFSP has confirmed that they accept the payment, and the second is after the creditor DFSP has accepted. Before acceptance, we need to support timeouts, and we need to support timeouts at the last current point in the chain of messages, because we still want to be able to time a message out if it doesn't get to the eventual creditor institution. When this point moves, the timeout evaluation point will move with it. But after acceptance, the payment is irrevocable, and if messages are held up, they must be retried until they get through. So the rule that we need to apply, before I get onto the rule that we need to apply, I want to say that we had a long and detailed set of discussions on this point when we were thinking about it in relation to a single scheme. I know Miller will remember that with affection. The point that we came round to is that of saying that there must be a single source of truth for timing a payment out, and that single form of truth must be the switch. Now, the question that we needed to answer here is, what happens if there are multiple switches involved? And the answer we gave is there must be a single switch, and it should be the switch to which the creditor party is attached, because that's the last switch that will get the information. It's the switch to which the recipient of a get transfers request will be sent, and it's the most likely to be able to time or to need to time a transfer out. Pardon me. So that's the reasoning behind our thinking. The rule, therefore, is when a switch receives a transfer execution request, and this is only about a post-transfers request, it should implement timeout checking until it's forwarded the request to a proxy and received a 202 response from the proxy. When it receives the 202 response, it knows that the message has got through and the proxy is now responsible for it. When it receives the 202 response, it should turn its timeout checking off. When a proxy receives a transfer execution request, it should implement timeout checking. I'm going to reword this because we've done some further thinking about it. So when a proxy receives a transfer execution request, it will forward the message to its switch on the other side. When it receives a 202 response from the switch, it should send back its 202 to the switch from which it received the message. Now, that's a kind of semi-complicated rule. So I'm just going to work through in some detail how that's going to work in practice. We start off then with two schemes connected by two proxies and a creditor DFSP. First of all, we post the transfers to the switch in scheme 1, and that now has the active the active timeout check. It reserves funds against the debtor DFSP's position account, and now it forwards that request to proxy 1. Proxy 1 forwards the message to scheme 2. Scheme 2 receives the message, gets the reservation against the proxy 1's position account and sends a 202 back to the proxy. The proxy sends the 202 back to scheme 1, and that is the signal for scheme 1 to turn off its timeout check. So now the active timeout check is running in scheme 2. Now what happens is scheme 2 forwards the request to proxy 2, and proxy 2 posts the transfer to scheme 3, which reserves 100 Kenyan shillings against proxy 2's position account. Proxy 2 then sends back its 202 to scheme 2, which turns off its timeout check, and now there is only one active timeout check, which is in scheme 3. And scheme 3 forwards the request to the creditor DFSP, but the active timeout remains in place. So what happens if the debtor DFSP can't reach its switch? Nothing happens. The debtor DFSP times out and returns its customers' funds. If scheme 1 can't reach proxy 1, then scheme 1 times out. It cancels the funds reservation against the debtor DFSP and returns an error message to the debtor DFSP. And the debtor DFSP returns its customers' reserved funds. If scheme 2 can't reach proxy 2, then scheme 2 times out, cancels its reservation, and we go back through the process. If scheme 3 can't reach the creditor DFSP, it cancels the reservation against proxy 2. It sends an error message to scheme 2. Scheme 2 cancels the reservation, returns an error message to scheme 1, and we go through the reservation process back to the beginning. And finally, what happens next? We say a transfer is irrevocably finalized once the creditor DFSP has confirmed it, it's returned the fulfillment, and the creditor DFSP switch has accepted the creditor DFSP's confirmation and created an obligation. Once that's happened, its status can't be changed, and therefore the confirmation message is passed back through the chain to the debtor DFSP, and if any of those links can't be reached, the switch or the proxy needs to retry until it can be reached. But no intermediary may time this process out. So that's all I have to say on deterministic finalization of transfers through timeouts.
So thank you very much, Michael, for detailing a lot of the design that the work stream has been working on. So in summary, what we've basically defined and what Michael presented. We define what is a proxy and how it works exactly. We define how we're going to route an address resolution, an agreement of terms, and a payment from one scheme to another. So Michael also covers the routing logic and how a DFSP is linked to a proxy, and how also we basically define a list of proxy and how proxy is a specific role. We've also defined how timeouts work. I've noted your comment, Miller, so we'll basically work on a different term to call this. And we've also defined and explained how settlement works and how the settlement of each scheme is actually independent from one another, and how obligations are recorded and how a reservation is converted to an obligation. So this was basically really the focus of this PI, as I mentioned earlier, designing a full solution that supports an inter-scheme model. So for the next PI, next slide, please, Michael. Our focus will be to complete some of the definition work. So it's basically mainly reviewing the next level of details that we have documented, and also taking into account any feedback that we are getting. The second thing will be to actually build all of this and have a working system, because we are already planning for this to be live by just after mid-November, when the end of this PI is mid-November. So for us, this PI is going to be extremely busy and extremely significant.
Can I just add something to that, Julie?
Go ahead.
And I hope that the architecture that I've sketched out here can be implemented with a relatively small amount of changes, and all of those, we think, to the switch. So one of the things, obviously, that was in our mind was the fact that we would need to deploy an interscheme quite quickly. And therefore, we tried to cut down the amount of work that implementers would need to, or the amount of changes that would need to be made to the Mojaloop system in order to support it. And I want to thank everybody who's contributed to those discussions for their help in achieving that objective.
Thank you, Michael. And I think like it reminds me that I should have said something. So when I talk about build, actually there is the build of the functionality per se, but there is also like the improvement of our regression test suite, so the TTK test, to make sure that all the new scenario with an interscheme context are also covered. Because obviously it's a new scenario that we're supporting. So today we don't have any test within the TTK covering this. Okay, next slide. So we always welcome participation in the work stream. So we have a Slack channel. I'll put the detail of the Slack channel here, and because this work stream is meant to finish by mid-November, compared to other work stream, we actually meet every week. So every Tuesday at 8 a.m. UTC. If you go in the Slack channel, in the description, you will see like the Zoom link to connect to the meeting.